All right, what you're looking at right now is the cleaned up screen of what I had for you earlier in the week. And on here, you have the charges of all the ions that you could possibly have for this put together stuff that we've been doing this week. And it's kind of like we've had false starts, but we're going to be good. And tonight's homework, which is right now it's the 2nd of February, so this homework will be due on the 5th, on Monday. And it's the same assignment you had before, but we're going to work it differently. So watch carefully and learn the new method. We're not going to use it forever. It's just a learning crutch to help you get the hang of how these things are put together. So here we go. I'm going to go ahead and get rid of these. And now I'm going to show you how this actually works. So in your new method, the first thing we're going to do is rewrite these guys without any subscripts, but we're going to get their charges. So, all right, now we're going to do the new method. And basically what we're doing is we're rewriting the chemicals that we're mixing, but we're not using any subscripts. We're just writing them as ions. And so what's the charge on lead? 2 plus, right. And what's the charge on nitrate? 1 minus. Okay. And now we're going to do manganese. Not magnesium, manganese. A lot of us mix those up from time to time, myself included. Okay, so not to worry about that. Manganese, what's that charge? 2 plus. And sulfate? 2 minus. Okay, once you do that, we're going to check and see where the subscripts come from. Now, if you look right here, I'm going to change color. If you look at this 1 minus, that becomes the subscript that should go right there. And it is, right? How do I know there's a 1 there? It's not written. Yeah, it's not a 0, it's just 1. All right, then we're going to take the 2 plus, and you see the crisscross is so close. It makes it really easy to match them up. Now, I'm going to do this again. So, manganese is a 2 minus, and, oh my, there's no subscript. Why? Oh, no subscript for the sulfate either. What is a 2 to 2 ratio?
1 to 1.
Yeah, that's why it's not there. We okay with this? Yeah? Okay, so we've done the right side. Now, I'm not going to write those arrows every time, but you can see that it's really nice to have the proximity. Yeah? Every period, it's been unanimous. They like that. Okay, they don't like writing all the stuff, but this you'll really understand after you do 7 problems like this. I'm not always going to have you do this. It's just a learning tool. That's all it is. And you're not going to have to do that much at home. You'll have 3 problems max. Okay, next thing. In this method, I want you to do the underline and the first element in the first molecule. Leave yourself some space and then do the first element in the first molecule, which is manganese, after you do your underline. Now, here's the thing you have to realize, and this method will just make it stand out like a sore thumb. So it's just wonderful. Lead cannot be with his partner nitrate on the other side. Okay, so who is he going to go with? Sulfate, right. Okay, the second molecules are always negative. Have you noticed here? See? The second molecule has to be negative. And just like with magnets, you can't put negatives with negatives. North to north on a magnet, they don't go together. You have to do them north to south, don't you? So, just like with magnets, you have to have opposite charges to get molecules to form. So, on the other side, our lead is going to go with the sulfate. Now, I'm not going to put in the subscript yet because I don't know if it's going to need it. And then over on the manganese, who's going to go with him? Nitrate. You bet. Okay, NO3. So now I have to do my charges again. And I know this is a lot of work, but bear with me and just grit your teeth and do it. He's a 2 plus, and sulfate is a 2 minus. And then we go over to manganese. What is his charge? 2 plus. And nitrate? Wow, yeah. NO3, 1 minus. So now we go back and we look at it and we're going to do the crisscross. So this 2 and this 2, what does that mean? What's the smallest ratio between these guys? 1 to 1. So we don't need any subscripts, right? And here we have a 2 to 1. So what's the subscript for manganese?
1.
And nitrate's going to be? Yeah, that's it. Okay, let's get them in there. Do I need a parenthesis with the nitrate?
Yes.
Absolutely. Because there's more than one of them. And so we're going to put the 2 subscript there that comes from this guy. And manganese is getting the 1, so we don't write it. Now we have a complete equation. Now what we do is we balance. See, we had to do all that just to get the equation. A lot of work, huh? Okay, but it's going to go faster as you get experience. So, here we go. How many leads do we have on the left? 1. How many leads on the right?
1.
Okay, nitrates on the left.
2.
2. How many nitrates on the right?
2.
Oh, my goodness, everything's matching. Manganese on the left.
1.
Oh, manganese on the right. Oh, sulfate on the left. And sulfate on the right. Oh, my goodness. What do I do when everything's 1?
1.
Indeed we do. Okay, so this is the ratio of 1 to 1 to 1 to 1. How are we doing? Is this making sense? All right. Now, I'm going to ask you to, those of you at home, I want you to stop the recording after I tell you to, and you're going to do the first thing that I did in that example problem. So let's stop the recording and let's see if you get that right. All right. Who would like to tell me what is the first thing? Putting these guys in, right? Charge for iron? 3 plus. And where are we getting that from? That little chart I did for you, right? That's in the whiteboard file a few pages back. Okay, and chloride is a 1 minus. Calcium? We're not putting them in. I'm glad I know. I'm not putting that in right now. Notice, up above, up here, that subscript is just nitrate. It's part of nitrate. It's the ratio of nitrogen to oxygen. So calcium and hydroxide. What was calcium charge? 2 plus. And the hydroxide charge? 1 minus. Good. Okay, so there we are. We got that part. Now I want you to do what I did next. So let's stop the recording and give you a chance to do that. All right, on the right side, we do the underline and the first ion in the first molecule on the left. Space, underline, and the second ion's first molecule or atom. In this case, it's an atom. Calcium. Okay? Now, remember I pointed out that iron cannot have his chlorine. So, who's he going to get? Hydroxide, yes. Now, we don't immediately know what the ratio is going to be. So let's go ahead and put in the iron with his charge. Okay, it doesn't change on the other side. These charges do not change on the other side with this kind of exercise where we're doing double replacement reactions. Okay, it's a particular kind of reaction where the molecules or the ions do not change. Okay, calcium, who's he going to have? Yeah, he's going to get the chloride. Okay, so calcium is what? Okay, he's a 2+, and chloride is a-. Okay, good. So now we can do our subscripts, can't we? Right? Okay, would you please stop the recording and try the subscripts. See if you know what you're doing. Okay, now to get your subscripts, we're going to take the OH and use that for iron subscript. Then we're going to take the iron and use that for the OH subscript. So how many OHs with the iron? Iron. Iron. How many? 3. Okay, so we have to use the parenthesis, or the 3 won't multiply the oxygen. So it has to multiply the oxygen and the hydrogen because together they are an ion, hydroxide ion. Okay, what's the subscript for calcium? 1, and chloride? 2. Okay, now we can balance the equation. So the groups of 4. Yeah, never mind. Let's go ahead and just balance the equation. Okay, you folks at home, I hope you're stopping the recording right now and balance it on your own. See how you do. Okay, so first of all, we're going to check the iron. How many irons on the left? 1. Irons on the right? 1. Good. Chlorides on the left? 2. I don't hear enough people responding. Chlorides on the right? Better. Okay. Now, I'm going to show you the trick that I used before. What do you think I'm going to do? 3 and 2, absolutely. I'm going to take the 2 that the red arrow is pointing to right now. I'm going to use him for the coefficient of the iron 3 chloride over here. So that's going to guarantee me 6 chlorides on the left. And then I'm going to take the subscript here of the chloride here, and I'm going to make that the coefficient for the guy on the right. Okay, so we've got a 3 here, which guarantees 3 times 2 is 6, and 3 times 2 is 6. So in both cases, I've balanced my chloride. Now, since I've been messing with chloride, I've probably made a problem with the irons, and I have. Look. I have 2 irons here and one iron here. I'm sorry, 1 iron here. So what do I have to do with that? Multiply by 2. Okay. And now, since I've messed up my hydroxide, I've got to look and make sure that hydroxide is balanced, and it's not. So I can do the same little deal with my trick. I can take this subscript and I can put it up at the calcium hydroxide, and so I have 3 calcium hydroxides, which give me 3 times 2, or 6 hydroxides. Here I have 2 times 3, and that's 6 hydroxides. So that's balanced. But since I messed with this guy, now I'm going to focus on calcium. Calcium is 3 here. Oh, look, he's 3 here as well. So when we balance one thing, frequently you'll find you're going to balance more than one thing at a time. Quite by, it just happens. Okay? How are we doing? Are we making sense? I hope so. So let's go on and let's let the class do this one on their own. And I want to get everything cleared out. Now, as a group of 4, the group of 4 that will have a balanced equation with everything done according to my method, the first ones to do it are going to wind up with 2 points extra credit for everyone in the group. Okay, let's get going. And those of you at home, do it on your own. Stop the recording and look back after you've completed balancing. Now I want to say before I do this, I'm not going to write the guys down below, but I am going to complete things and show the charges. The hydrogen is a 1 plus and the chloride is a 1 minus. Yeah, 1 minus. 1 plus and 1 minus. Cobalt is 2 plus and 1 minus. And then this was what we do on the other side. We have hydrogen, and we got a lot of space, and then we have another underline in cobalt. And because you're on the other side, you got to swap partners, but in this case, the partners are the same. Okay, which is interesting, and interesting results. So I have a 1 plus with a 1 minus. It's good. A 2 plus with a 1 minus, and it's not good. So, how many chlorides do I need for the cobalt? 2. Okay. And I'm good on the other one. So, there we are. As you look, you'll see that we've got a perfectly good balanced equation. All right. Here we have HCl, hydrogen, there's one of them. Over here we have hydrogen chloride again. Have you noticed that the 2 products are the same as the reactants? You know what that means? There was no reaction. Okay, see, these guys are well matched. These guys are well matched, and you have exactly the same thing on both sides, because chlorine was the cation for both of the anions, the cobalt and the hydrogen. So, what do we do with a thing like this when we're trying to get it all balanced? What do we have to put in all of the underlines?
1.
Yep, just ones. Okay, so we got ones everywhere, and we have a 1 to 1 to 1 to 1. Okay, and we're going to do one more problem, I think. I'm not sure we'll have time. I'm not going to put this on the video. You should be able to do this on your own. Hopefully this method is going to work for you, and thank you so much for watching.